Hello again. In this video, we're going to go over section 2.5, part 5, which is about the end behavior of an algebraic function. Now, in previous videos, we looked at the algebraic behavior of polynomial functions and of rational functions. But in this video, we're looking at the end behavior of algebraic functions. Okay, so this example 5, we have an algebraic function. So let's find the end behavior of this algebraic function. Now remember, the end behavior of a function is essentially all about finding the y value that the function approaches as x approaches infinity and negative infinity. And so the first thing we're going to look at here is what happens to the y value for the function when x is approaching infinity. So I'm going to find the limit of this function as x approaches infinity first, and then we'll find the limit of it as x approaches negative infinity afterwards. Okay, so here's how we're going to do this. First of all, this is going to break up into two different cases. And let me try to explain why. What we're going to do here is, first of all, this function here, when you try to evaluate the limit of it as x goes to infinity, you get the form of infinity over infinity because the top is approaching infinity as x goes to infinity as well as the bottom. And so initially, this is in an indeterminate form because it's infinity over infinity. And so we need to do something to this function to make it determinable. And what we're going to do is we're going to multiply the top and the bottom by 1 over x cubed, except on the bottom, I'm not going to write it as 1 over x cubed. I'm going to write it as 1 over the square root of x to the 6th. Which in this particular case, okay, this is case 1 we're looking at, happens to be equal to 1 over x cubed. And let me show you why. The square root of x to the 6th is a piecewise function. It's equal to x cubed if x cubed is greater than or equal to 0, but it's equal to negative x cubed if x cubed happens to be less than 0 or negative. So in this case that we're in, x is heading towards infinity, right? This is the case we're looking at. So if x is heading towards infinity, at some point x needs to become positive. And so if that's the case, then x cubed would be positive. I mean, if x is positive, then x cubed is positive. Okay, so because x is heading towards infinity, we know x is positive at some point, so that means x cubed is positive. And so that means we're in the first case of this piecewise function. And so the square root of x to the 6th power is actually equal to x cubed in this particular case. And so when I write this out, this bottom piece is really the same as 1 over x cubed, and this is equal to 1. And so I'm multiplying this function by 1, which is perfectly fine because it doesn't change the value of the function. It only changes the form. Okay, so having said that, let's see what we get when we multiply by this particular 1, right? This is equal to 1, right? But we're going to change the form when we multiply this by the function. So we're going to change the form of the function. Okay, so let's see what we get. Distribute this to each of those. Okay, so when you distribute it to here, you're just going to be left with 10. Let me write it out. You'll be left with 10x cubed over x cubed. Here you're left with negative 3x squared over x cubed. And then here you get 8 over x cubed. And then on the bottom, you get this square root all divided by the square root of x to the 6th. Okay? So that's what happens when you distribute or multiply these together. But one thing I want you to notice is you can actually write this as one big square root. And that's simply because the square root of a divided by the square root of b is the same as the square root of a divided by b. So these are the same. Okay. So that allows me to simplify the stuff inside of here. Okay. So we'll do that in a moment. So x cubes cancel, right? You're left with 10 here. Here you're left with minus 3 over x. And then here you're just left with 8 over x cubed. And then on the bottom here, this x to the sixth, and I'm just going to write it out this way, is divided into each of these individually. Okay, and so you're left with 25. And then here you're left with 1 over x squared. And then here you're left with 2 over x to the sixth. And then you're taking the square root of all of that. Okay, and then we're taking the limit of this as x goes to infinity. Okay, so notice that as x goes to infinity, these terms are heading towards 0. And so it looks like the top is getting closer to 10, and the bottom is getting closer to the square root of 25. And so that's just 10 over 5, which is 2. Okay? So the end behavior for this function, as x approaches infinity, the y value is approaching 2, which, by the way, means there's a horizontal asymptote at y equals 2 as well. Okay, so that's what's happening as x goes to infinity. Now, let's redo this and find the limit as x heads towards negative infinity. But that's a different case, so we have to be careful about how we handle this. Since x is heading towards negative infinity, right, so we're going to find this limit now as x heads towards negative infinity, then that would mean x cubed would be a negative number. I mean, x is negative at some point, right? If x is heading towards negative infinity, it must be negative at some point. So then if it's a negative number, when you cube it, then that would say that x cubed would have to be negative. And if x cubed is negative, then when you take the square root of x to the sixth, since it's a piecewise function, you're actually in this bottom case. And so the square root of x to the sixth is not x cubed, it's the opposite of x cubed. Okay, and so when we go and multiply by this 1, we need to be very careful about whether it's actually equal to 1 or not. Okay, so let's take the bottom part and we're going to multiply on the bottom by 1 over x to the sixth. Okay, what is 1 over x to the sixth in this case? Oh, 1 over the square root of x to the sixth. That's what I meant. I can't remember what I said, but we're multiplying the bottom by 1 over the square root of x to the sixth, right? What is that? All right, 1 over the square root of x to the sixth is 1 over, well, what's the square root of x to the sixth? It's negative x cubed in this particular case, right? So that's what this is equal to. It's not equal to 1 over x cubed. It's 1 over negative x cubed. And so if I want this to equal 1, right, and it has to equal 1, otherwise I change the value of this function, then I actually need to multiply the top by negative 1 over x cubed. Okay, so this is equal to 1 in this case. And that's because 1 over the square root of x to the sixth is actually 1 over negative x cubed in this case. And so this would equal 1 in this particular case. Okay, so having said that, now let's go back and find the limit as x goes to negative infinity in this case. Now, again, originally this is an indeterminate form. I think it's negative infinity over infinity or something like that. So it's indeterminate, right? And so I'm trying, by multiplying by this particular one, I'm claiming that we'll get it into a determinable form. Okay, so let's see what we get here. Essentially, you get very much similar to what we had before, except we're going to be distributing this minus sign as well. So let's see, we get negative 10 x cubed over x cubed. And then we'll get plus 3x squared over x cubed. And then minus 8 over x cubed. Now notice these are changing sign because I'm multiplying by negative. So that should be a negative, a positive, and a negative. Negative, positive, negative. Okay? And then on the bottom, again, we get this square root all divided by the square root of x to the sixth. But like I said before, you can write this under one big square root. So I'm going to write it like this instead. It's actually the same as the square root of this entire fraction. Okay. And now, let's just go through and simplify this. This becomes negative 10 because the x cubes cancel. This becomes 3 over x. And this is negative 8 over x cubed. And then down here, I'm going to go ahead and just write this out. This x to the sixth power gets divided into every one of these terms. Okay, so here you're left with 25. Here you're left with 1 over x squared. And here you're left with 2 over x to the sixth. And then you're taking the square root of that entire thing. Okay? And then so let's see what this limit is as x goes to negative infinity. So this term here is going to head towards 0, right? So is this one, and so is this one. And so is this one. And so it looks like the top is going to get closer to negative 10. And on the bottom, you're going to get closer to square root of 25. And so you end up with negative 10 over 5, which is actually negative 2. So notice that the difference between case 1 and case 2 is simply a minus sign. And that should make sense because in case 2, we introduce this minus sign here because of this piecewise function. Okay, so now we have a horizontal asymptote at negative 2. You know, as x approaches negative infinity, the y values for this function begin to approach negative 2, and then we have a horizontal asymptote at negative 2. Okay, so we found the end behavior for both cases, right? As x goes to positive infinity, y approaches 2, and as x goes to negative infinity, y approaches negative 2. And so let me show you a graph of this, which will kind of solidify what we've done. This is actually the graph of that algebraic function. And so you can see as x goes to infinity, the y values begin to approach positive 2, and you have a horizontal asymptote at y equals 2. And then you can see also that as x approaches negative infinity, the y values begin to approach negative 2. This is y equals negative 2. And you also have a horizontal asymptote at y equals negative 2. Okay, so that's the end behavior of this function. Okay, so I hope you found this video helpful. Thank you for watching. Bye-bye.